Welcome. This video is all about getting you introduced to the jscad-electronics repo. This is going to be a huge data set of 3D models for electronics, but not just that. The models have parameters that allow you to generate variants of them. And that's very, very powerful because you have chips with different numbers of pins and many variations of resistor sizes and all of this. And so we can generate many new models from our parameterized models. So that's why we code the models. That's why we don't create them in a traditional tool. What this means is that when AI generates our electronics, it can use our library of parameterized models to kind of like tweak things and make it right for the design or whatever it's modeling. So that's what we're doing. This repo is a medium difficulty repo, so you might want to start on schematic symbols or footprinter if you're looking for an easier project. But this video is mostly just going to be showing you how it works. So we're going to dive in by implementing the axial resistor model. So a resistor looks like this. You know, it's got kind of this body part, and then it's got two wires that stick down. And here's another version of it. There's a bunch of resistors. So that's what we're going to be implementing. Yeah, that's it. Let's jump right in. So I'm going to open up the repo. And then I'm just going to pull the main branch, which I've aliased on my system just to the word main, but you might have to do git fetch, git checkout origin main, something like that. And then one of the first things we're going to want to do is make sure we install and are able to run the project. So you just do bun run start. For all of our projects, you just do bun run start to get them started. And then we are greeted with this window. This is called Cosmos. It's a lot like Storybook if you've ever used that, but it lets us click on different things and kind of debug our models as we build them. So this is basically like our preview, like our website preview. We're going to create a new example. These are all called examples. So we're going to create a new example for our axial resistor, and then we'll start programming it. So let's get started. So to create a new example, you just need to create a new file in the example directory and give it this extension .example.tsx. So I'm just going to call mine axial resistor.example.tsx. And I'm just going to go to any model file. They almost all look the same. Copy and paste it in. I'm going to comment out that model because we'll use our own. And then usually when you're doing a model, there are footprints that you want to look at. So these red pads, these red pads on the bottom of the chip, that's the footprint. And that can help guide you when you're modeling. Now, a lot of the time, those footprints are incorrect. They might be not spaced correctly. Like in this case, the footprint is actually incorrect. So that means that there's a bug in the footprinter repo. But in many cases, this can also be very helpful. So we are going to use it. We're going to set down an axial footprint. So let's see, my design is right there, axial. And right now it's rendering an 0402, which isn't really right for us. And then another thing I'm just going to note is it's nice to do this show grid. When you do show grid, you get this nice grid. It kind of helps you keep track of what's where and how big things are. So instead of 0402, I'm going to type axial. No function found for footprinter. So let's update tscircuit/footprinter, see if it's in a newer version. And then we'll do bun run start again. I think it should be in there. Yeah, there we go. And that's it. So now we have our axial footprint. But we're going to do the horizontal variant of the resistor. There is a vertical variant, but we're doing a horizontal variant. And so that's not really spaced far enough apart for me. So I'm going to change the pitch. And if you're not sure, like this syntax I'm using right here, a lot of people don't know this off the top of their head unless they've worked with Footprinter a little bit. So if you go to tscircuit.com and you click AI footprint generation, you can go to an AI tool that will help you generate these. So because axial is so new, I don't think it could generate axial, but we can try. So generate an axial resistor. So yeah, it didn't generate it properly because axial is too new. But for most other things, this will work. So it's like chip with 8 LEDs dip or something like that, whatever queue you have, and it'll generate it. So we have our axial footprint. That looks pretty good as far as distance goes. Looks pretty wide. And so now we get to think about, okay, how is this going to work? How are we going to draw this resistor and get it working? So there's 2 wires, and we can probably clone that on both sides. And then there's this kind of bigger part, right, for the resistor. So you just kind of think about it. And then what we're going to do to code this is, well, first we have to create the file. So let's create a new file in lib, axial resistor.tsx. I'm also noticing the naming convention is a little different. So it looks like we're doing Pascal case. So I rename that axial resistor, axial resistor.example.tsx. And then let's copy over a component, like, let's see. It's useful to find a component that's kind of similar. And if you can't find one that's similar, just copy something simple. So the 0402, which is the 2 square pads, is a really simple one. So I'm actually going to start by copying that over. Most of these dimensions aren't relevant, and we don't necessarily want to use cuboids. So a cuboid is like a rectangular prism. I think we are going to have a cylinder, so we can add a cylinder. And then I'll call this pin distance. And I think we set that to 0.4 inches, which in millimeters would be that much. Or, well, we can just use the millimeter module. We could be lazy. Oh, we don't have the, yeah, we have it. Okay. So we're going to do millimeters, 0.4 inch. Call this default pin distance. And then we'll name this component axial resistor. And maybe I'll just throw in kind of a random cylinder here. Height 1, radius 0.5. I'm just putting in random stuff. Okay, so we're just gonna do that for now. And then we need to import that, and we should see it. So there's our new axial resistor. There's our cylinder. So this is kind of how we draw it. For this resistor, because we have a wires on both sides, I kind of want to use a thing called a, there's a type of extrusion that you can use in JSCAD. So whenever you're like, oh, there isn't enough reference stuff for me to use, our Reacts library, our 3D Reacts library is built on JSCAD. So you can go to jscad.app and you can take a look at the stuff they have. And what I'm going to look for is somewhere where they like, kind of like extrude a sphere. I see this, and I think that's extrude rotate is what they're using. JSCAD also has docs, so we can look up the JSCAD docs. For a lot of the time, you don't need to do this. You could get away with just using a cylinder and stuff like that. But I'm going to see if there's a way for me to make this wire. I'm really curious what this extrude Bezier does, because it uses extrude from slices, which seems like a power user extrusion. So I'm really curious if that's a good one. So I'm going to delete everything else so that I can isolate what's being used. So it looks like it's doing this shape, which is super fancy. Okay, so I just did some testing and I used Claude for the testing too. I just gave it the program and asked it to adapt some things. And I found out that this will basically do what I want. So you can make this really generate a lot of different shapes. This is like kind of your generic extrusion. What you have on the bottom, this is called a slice. And a slice is a set of edges in 3D space. And I just read this all on the JSCAD docs, right? Basically you just can say, okay, I want you to extrude an object over 20 slices. So there's 20 like segments in here. And then you can put the slice position, you can move the slice wherever you want to. And so what I could do for these wires is I could have a circle on the bottom, and then I could kind of draw a path that is like a 90-degree angle and it's arbitrarily long. And I can use that to draw the wires out. Maybe I could even use something like this for the resistor, although I think the body of the resistor might be a lot easier. So let's dive right in and try to implement it. So first problem, we don't have extrude from slices from jscad-fiber. It's not exported. So we're going to actually go to jscad-fiber and implement that. That's just another TS circuit repo. And a lot of times when you see a repo and you have a bug, just think maybe this could be a TS circuit repo. Check it out first, because a lot of times the bugs are inside of TS circuit repos where the code is fairly consistent and you can probably contribute. So let's open up this repo and see if we can introduce that new function, extrude from slices. Okay, so I'm just copying files around. I added this extrude from slices file, basically just copying stuff. I'm going to look at the JSCAD docs to figure out all the props that I need to add. Okay, they have a page with all the props I need to add. So I see number of slices. Okay, so I added all the props. It took me a while to figure out what a slice was. It's just an array of edges in 3D space. So now it's giving me this error: extrude from slices does not exist on JSX intrinsic elements. So hard to find out what's going on there, but let's look up intrinsic. Just pick a word that's kind of hard. And I can see they're all defined here. So now we can do extrude from slices. And this technically is not a correct type, unfortunately. So you can see how some of these have it manually defined. You're actually supposed to manually define these because this higher level thing will do. This is a slightly different type. We have to use the pure types. So yeah, we sort of have to use this. And I get it, it's pretty unclear why, but the reason is basically has to do with sometimes we convert units. We convert millimeters to inches, but JSCAD only takes numbers. So a lot of times the uppercase component is a lot more forgiving. We might accept like inches or something like that. But we don't do that with the lowercase ones because we try to be true to jscad-fiber in those. Okay, so we're no longer getting errors here. Now we have to actually do the implementation. So we've kind of defined some stuff, but we haven't done an implementation. So let's see where that is. Let's actually, even better, let's make a test. It's the same thing as before. We have this examples directory. So we can just put in extrude from slices.fixture.tsx. So whatever the project uses, this project uses fixture. I'm going to copy this out. I will do show grid because it makes life easier. And then we're going to import our extrude from slices. And then we're going to do our best to make this work. So this is one of the hardest parts. You've got, we're super deep in the stuff, like what's going on, right? So what we're going to do is use that jscad.app to help us figure out these parameters. We're almost going to copy them out of jscad.app, and that's going to be really helpful for us. We also see there's a little bit of an export error here. So for some reason, it's not being detected in the library export. So let's go ahead and fix that. It's probably just not being exported. Yeah, it looks like we just need to export it from this index file. This is called a barrel index file, and you'll often have to export from them. And again, just as a reminder, everything we're doing right now is to be able to create a wire for our resistor. So it can be a lot of work to do something very basic, but we're doing our best. We're going to get there. So I'm going to copy out the callback parameter here so that we can kind of use that same callback. And then we have a bunch of stuff to import. We'll get to that. We also have this base slice, and that's what the base slice is here. So let's copy that too. We'll call this the base slice. Okay, so there's all these utility objects from JSCAD. So let's go ahead and import those. I think we might be able to import them just from JSCAD. It looks like it's not in JSCAD modeling. It might be in something else. So I'm just going to scroll up here and see where it's in. Oh, maybe it is. I just have to do this. And then I can say, yeah. Where is it? Okay, so I can literally just copy out everything in that example thing, and it should work out. Some of these are unused, so we can delete the unused ones. Okay, did we get everything? It wants this Y curve, X curve. So I will add the Y curve, X curve. Okay, so for some reason there's a type error, and this might... Yeah, I'm not 100% sure because this comes from some other program, so I'm just going to anycast it for now. Height isn't defined, that's true, so we'll just do 10. And then it's saying that type isn't valid. So let's take a look at our type. Yeah, we didn't do this type right, so let's do that instead. And then we also have to fix the type in our definition here. Okay. Okay, it's passing, so let's see if it works. Same thing as jscad-electronics. I'm going to do a bun install, then I'm going to do bun run start. And it gets me a port, and I can open up Cosmos again. So even though it's called example there and fixture here, it's all the same thing. It always uses Cosmos. And I'm going to search for my fixture. So the name of this was, what was the name of this? Extrude from slices. Okay, so we got a renderer error. So let's take a look. It says unknown element type extrude from slices. Whoops, just making that as big. Unknown element type extrude from slices. So like, you see this kind of stuff and it might be like, ah, man, I must have messed up along the way. Usually there's a lot of errors on the way. So this is actually a good error on the way. We're back in jscad-fiber. we want to figure out where that error is coming from. So that error was unknown element type. So we're just going to search that in the code base. And we can see the error is being thrown here. And it looks like we just need to add handling. So let's find out where the other extrusions are. So that here we have some extrusions. So we'll just do the same thing. So case extrude from slices, and it's already auto completing. We'll import those props. And it looks like the version of JSCAD we have defined here, JSCAD module. Oh, wow, we defined the types ourselves. So we need to define the extrude from slices function here. Thank goodness for AI. We'll import our slice object. And it looks like what everybody's doing is returning any instead of returning like a 3D model or something like that. So we'll just keep doing that. This guy also needs the callback. Okay. So now we have that defined. Oh, we forgot to, I just realized we made a mistake in the fixture too, but that's not related. Okay. Okay, so we just need to feed in the parameters according to the documentation. So that's how the docs said to do it, I think. Actually, it's a little different than this. According to the docs, you have to give the base slice as the second parameter. That's how it works. I don't know if I'll be able to find it. Yeah, square slice is the second parameter. I don't know why they do that. They could have just used all named parameters, but... Okay, I'm just fixing up some parameters here and making sure they all match, and then importing everything. But one of the problems was base slice is actually required, so. And that's it. So we did it. Let's go back to our example and see if it's working. Okay, looks pretty good. This one is on its side. I don't know why. Let's fix this view a little bit. So for some reason it's on its side, but I'm sure that's just me changing the coordinates. Sometimes when you see something on its side, it means that if you go to the fixture or example object, there's a parameter called z-axis up, and what it'll do is change which axis goes upward. And so that kind of fixed it in this case. So now we have this awesome extrude from slices function, which we can use to create our wires. So let's get this into a PR, and then we'll go over to jscad-electronics, create our wire component, then we'll create the resistor body, and we'll have a resistor. So I'm opening a PR up. There's our PR. We're just going to make sure everything passes. Looks like we're failing a type check. So when you fail a type check, you can just run it locally, or you can hop in here and see what the issue might be. Sometimes it'll look like it's not related. So let's figure out. So I just ran the type check locally just to make sure that we're not too wrong. And then I'm hopping over to this element. And it does seem strange. Cube does not exist. So maybe we accidentally deleted cube. So I'm going to check the diff to see if I accidentally deleted cube. Yep, there we go. Somehow, when I was accepting the AI thing, I accidentally deleted cube. And that's the great thing about these tests. They catch stuff like that. Okay, I've pushed my changes up, and we'll see if it passes this time. Okay, it looks like it's passing now. Let's go ahead and merge. So a lot of times you'll be waiting on a review and you'll be like, oh, I can't move forward. You can also use Yalc. So Yalc is this package, work with NPM repositories locally like a boss. Yalc is amazing. And what it does is it lets you publish and then use your own package locally. And so you don't have to wait for anybody if you're using Yalc. You don't have to wait for the PR to merge and then for the release bot to release the new version. Since I can merge my own PRs, a lot of times I do wait for them to pass and then merge it. But Yalc is really the way to go when you're working with a big team. And when we get more contributors and people start reviewing my stuff, I won't do that. I'll actually use Yalc and I'll wait for people to review. Okay, so we can see the released version is 0065, so we're going to load that in. So we're in jscad-electronics now. We're going to do update latest, jscad-fiber. And we can see we got version 0065. So, like, just refreshing ourselves where we were on this. We have a new version of jscad-fiber that lets us extrude from slices. But basically where we were is we just have this cylinder rendering. And what I want to do is make the cylinder stretch up, right? And then curve around at a right angle and then kind of like go into a body. If we want to be really lazy, we can also have it go up and go all the way down to this hole. We could do a wire like that. So to do that, I'm going to create a wire component that we can use for just kind of generally creating these wires. I think that'll be the easiest way to do it. So I'm sitting here and I'm thinking it would be cool if we had a wire component, but I could also just put a cylinder and a sphere together to create the rounded edge and do that. So let me just experiment with this approach. Like, I think this is the case where there's multiple right answers. So we've got our cylinder. Let's say that the center is at that red line over here. So you can kind of use these holes to count. So I think each of these is a millimeter. I could be wrong. Let's find out. So 1, 2, 3, 4, 5. I have a feeling it's like half a millimeter. I'm going to do that. So I set the X to negative 0.25 and let's see what happens. Okay. It seems like it's much more. Let's set it to 25. Okay, that's too far. Maybe it is just 2.5. No, what's going on? Or wait, no, I counted 5. Yeah, okay. It was exactly 1, 2, 3, 4, 5. Okay. So we've put the cylinder there. And then I think what I want to do, let's bring it up. And I'm going to move the Z position so that it's centered too. So now we've got that. That's a little bit high. So I'm going to set that to 3 and then that to 1.5 just to make it a little lower. It's still a little bit high, I think, but also it is supposed to go through the board like that. That might be okay. It's supposed to go through the board a little bit. It's actually supposed to go probably about 1.4 through the board. So we could say board thickness, and that's going to be, I don't know how much that is, but I think it's like 0.1-ish. Maybe we'll keep it simple for now. Basically, I want this thing to go below the board a little bit more, and I'm just messing around until I get it somewhere where I think it's about right. Okay, I feel okay about that. Now what I'm going to do is put a sphere at the top of that to form the corner. Okay, so we're going to do sphere, radius, and we need it to be equal. And then we're going to set it on top of that. So that's 0.5 plus 2, or the height divided by 2. And sometimes it's nice to keep these equations kind of built out. saying center doesn't exist. So I think this is another bug in jscad-fiber. So whenever you see a bug like this in jscad-fiber, it's a good idea to go back. I will go back and add support for the center property. So we'll go to jscad-fiber. And we're going to look up sphere. And we can see the sphere has the width color prop, but it doesn't have width offset prop, which other things that have the center do have. So I think width offset prop gives it a center. And what that does internally is just creates a translation. Okay. Let me make sure that that order is right. Okay, I think that's right. So we're going to do a new PR, sphere center, create center for sphere. Okay, looks like it's ready. Let's merge. And now we can go back again to jscad-electronics, update our dependency. Okay, so now we've got the sphere. I just updated the dependency, and now we can see that the sphere has the center prop without an error, and we have the sphere on the top of our cylinder. So now let's add another cylinder that points towards the center, right, to create the other part of the body, or to connect to the body. So another cylinder. This time we're going to rotate it. Now, a lot of components don't have rotation built in yet, so I will use the higher level prop for this. Rotation is kind of confusing, so I think it's fine that rotation isn't built on a lot of these yet, but it definitely should be. So how do you know? Oh, yeah. So a couple things. One is that you got to put 90 degrees in strings as a string right now. If you just do 90, it'll come out really weird. So we have to figure out how to rotate this guy properly. And okay, so I was actually looking at this and this won't work. We need to go introduce the JSCAD property onto cylinder if we want this to be ergonomic. The only other way to do it is really hacky, and we would need to have a translate and a rotate, and we couldn't use center. So instead of that, we're going to jump into the jscad-fiber again, and we're going to fix it so that it has a way to rotate. So to do that, we're going to copy out this same function, and we're going to do with rotation prop.tsx, and we'll rename some stuff. Okay, so we're going to continue introducing this with rotation. And there's a lot of weird stuff in here, but it's mostly just changing names. You don't have to worry about too much. So what's up with the types in here? What we're saying is whatever type you give this, it's going to extend the types of whatever you give it. That's all this entire thing is saying. So it's not that complicated. Now that we have with rotation defined, let's go to cylinder and let's define, by the way, I think the color prop is supposed to be the last one, or the one most on the outside. And then we'll do with rotation prop. Whoops. And because this is a new prop, I think you can't just commit the code and expect the types to save you. We actually have to go in there to our fixture and actually do a really quick test to make sure this works. So let's run button run start on jscad-fiber and open it up. Okay, so this is in wireframe mode, which is why it looks kind of weird. So that's fine. Just to make this a little easier, I'm going to do show grid. And I might actually turn off wireframe. I think it'll make life easier. It's really big too, so let's make it a little smaller. Okay, so we've got our cylinder defined. I think I'm going to do one last thing, which is I'm going to make z-axis up on, and I'm going to move it somewhere to the right, I guess, or maybe negative 20. So it's like really far over there. Now, when we rotate it, rotation can be weird because it needs to rotate around the center of the thing. And often when you rotate something, it doesn't rotate around the center. So that's why I moved it, made sure it wasn't in the center, because then we wouldn't know if it rotated around the wrong thing. So then we'll do rotation. And we'll rotate it over the x-axis, which it's very hard to keep track of axes. So, that's okay if you can't. It's saying that it doesn't want to accept a string, but we accept strings in other places, so I'm going to figure out how to make it accept a string. Okay, so it looks like there's this function process rotation, which will handle it, but it's not exported, so we're going to export it. And now we can import this. And then the types are also kind of bad. Like, look at how these are defined. It's kind of defined in a crazy way. So we're going to do 0.3 or string. We'll say rotation value. Okay. I think it worked. Okay, so this is going to be maybe the best way to do this test to show that it's working is to do 2 cylinders. So we're going to do one at 20 and that's not rotated. That has no rotation. And then at negative 20, we're going to do our rotated one. And now you can see that one has rotated. So we've successfully added the rotation property to cylinders. And now other people, if they want to add that rotation property, can just use the helper that we've defined. So let's create a new branch and push it up. Okay, we're returning back. Hopefully now we can finish this thing. So jscad-electronics, we've got a cylinder. We're going to update jscad-fiber to get that rotation property. Hopefully it's a lot easier for you to do this because you might not have to go to jscad-fiber. It's almost like I got unlucky and I had to go implement a bunch of stuff, but also don't be afraid of it, right? So we want our cylinder. It's like for now, we can almost think of this thing as being centered, right? And then let's rotate it. Now, when you're thinking about axes to rotate over, it's really hard to remember what the axes are, but just from watching how this design has gone, this is the x-axis and this is the y-axis. So if we want to rotate around the y-axis, we just set rotation, the center one, XYZ, the center Y to 90 degrees. And you can just mess around with that. If it doesn't work the first time, just change where it is. You'll figure it out. So this parameter keeps coming around, and this is the sort of like center of height to center of resistor is what I'm going to call it. So I'm just going to copy this out. And a lot of these numbers are going to change too. They'll probably swap out with other variables, but that's fine. Everything helps. Okay, so now it's kind of floating there. Let's move it to the left. And where we want to move it is halfway to this, which is, since it's -5, it would be -2.5, right? And there we go. Oh, yeah, that doesn't look very good. So we actually probably want to go into the sphere, right? So to go into the sphere, we have to go into half the sphere radius, so 0.5. So very simple. And there we go. Look at that. Not bad. Pretty simple. It was a pretty good approach. So we can control how long this is with this height property. I'm just gonna leave that for now, but there's some interesting things we could do with that. For example, it doesn't seem that bad to me to make it go all the way to the other pad. So that might be one thing we can do, or we could reflect this on both sides. Who knows? Anyway, let's do the resistor body. The resistor body is best created with an extrude rotate. And the reason why is it has a weird shape. There are a lot of examples of how to create weird shapes in jscad.app that you can use as inspiration for creating weird shapes. Particularly in extrusions, there's a lot of ways to rotate around things. So if you look at this, it's kind of like rotating around. So there's a lot of ways to create a resistor via rotation. And the reason you want to do that is they kind of have this weird shaped body. It's kind of like pear-shaped. But that being said, we don't have to be perfect at first, and I know this tutorial is going on for a long time, so I'm going to do that in a future issue, and that's totally fine. It's better to have something than nothing at this stage. So, to simplify everything, we're going to do a bunch of things at once here. We're going to center our cross wire, okay? And I'm going to make it 10 so that it goes all the way from center to center, which is 10 because of the default pin distance. Oh, we never used this. Yeah, I don't know. Anyway, it's 10 because somewhere, yeah, we said, I don't actually know why it's 10. But it's perfectly 5 millimeters. I don't know, maybe 0.4 inches is almost perfectly 4. Oh yeah, it's almost perfectly 10. So that's why all of our numbers are slightly off, but that's fine. Okay. And then I'm going to create another cylinder and sphere. And I'm just going to invert that 5, right? Okay. So now we've got the wires, and then I'm going to put in another rotated cylinder, but I'm going to give it a bigger radius. I'm going to set its height to 4. I'm going to put it right in the center, and there we go. Let's make it a little bit smaller. Oh, actually the height was okay. I think the radius is too wide. Something like that, maybe a little bit bigger. Okay, cool. So now we have something resembling a resistor. We didn't do the right thing on the body, but that's fine for now. We'll be lazy, but there is a really cool way to do it with extrude rotate. Let's make the height slightly bigger. Yeah. Okay, cool. Another thing we can do is set the color. Setting the color can indicate it's slightly different. So here we set it to red. That's like not the right color. It's more of like a tan. I don't know if tan is oh yeah, look at that, tan. Okay, cool. That's a lot of resistors are tan, or like a teal blue. Okay, so now the problem is this resistor doesn't really adapt for different sized axial holes, so it doesn't take any variables. So let's make it take a variable. So we're gonna add some props, and I'm gonna go ahead and create an interface for this. Height is a pretty good one, and radius is okay, but what I want to do is the pitch. So the pitch is the distance between the holes, and that's what's going to vary the most. We're going to set it default to what we have right now, which is 10. They're about 10 apart. Then everywhere where we have like this -5, we're gonna use that. So let's just say set that to pitch divided by 2, pitch divided by 2. And you can create a variable for that, but like you could call it half pitch or something like that. But a lot of times I find that that's almost more confusing to have more variables. So, use your best judgment. Or for some of you, use your AI's judgment. Okay, so we haven't really done anything except change that pitch to be programmatic. Okay, so really quick, let's fix this in here. 0.4 is the same as 10 millimeters. So we'll just change that. And we'll put 10 here. Okay, so now it's generating right, but let's do something else. I wonder if I can translate this. That'd be really cool if I could. I'm thinking it would be really cool if I was able to translate these. Okay, you can't use multiple children. Let's try this. Cannot convert a symbol to a string. So I think this is a jscad-fiber issue. I think it's because the axial resistor internally has a lot of shapes inside. So I'm basically asking to translate. Yeah. What I'd like to do is have multiple resistors. Just like we had the multiple cylinders, I'd like to have multiple resistors if we can. I'm going to try one more thing. I'm going to try doing a union. See if that works. Oh, we got another error. Cannot convert a symbol value to a string. I'm just going to try a couple different variations of this before we give up. I can also turn this whole thing into a union, but that messes up our colors. Because JSCAD doesn't support colors very well. Yeah, nothing's working. Okay, so it looks like we can't currently have multiple resistors in the same thing. So what I'm going to do instead is just manually run a quick test. So right now it's at 10. Let's see what happens at 8. Or let's see what happens at 20. Looks like it works. So we have a nice parameterized solution. So now we can generate thousands of different resistor layouts for all the different ways you might want to plug in resistors. And in reality, resistors do plug in many different ways. So I think this is very useful. This is a good starting implementation. Somebody can come along and make this better, and we can add features onto this, but this is a pretty good starting implementation. So that's it for this video. I'm going to put this into a PR and get it merged, but hopefully this was a good introduction to jscad-electronics and jscad-fiber. Good luck with your contributions. There's a big issue list. So you've got a bunch of things labeled good first issue to get started. We have so many. There are literally thousands of things to build. So thanks a ton for listening, and good luck.